In this video, I'm going to do a few more examples solving linear equations with two variables. However, they're not going to look quite so clean at the start. So the key is we always want to put it in a usable format. If I look at this first problem on my screen, I want to solve this thing. But when I look at it, it's really not in a very easy to use format. There's nothing I can solve for directly. I can't solve for one of the variables to substitute, and I also can't eliminate very easily because there's variables all over the place. So the first thing I'm going to do is I'm going to rework these equations to be simple x, y's on one side, everything else on the other. So I'm going to start with this first equation. First thing I'm going to do with the first equation is I'm going to distribute that 3. 3x minus 3 plus y equals 6 minus y. Next thing I'm going to do is I'm going to get all those x's and y's to the same side. So I want to get all the x's and y's to the left-hand side. The 3x is over there, the y is over there. Let me take this other y and add it across. So we'd have a 3x plus 2y. And everything that wasn't an x or y, this negative 3, I'm going to move that over to the other side. And the way I'm going to do that is by adding it over. So add the 3 over, we get a 9 on this right-hand side. So now this is a much more usable form that I will either be able to solve for or eliminate. I'm going to do the same thing with the second equation. So I'm going to start by taking care of the distribution. Negative 2y plus 2x plus an x is equal to, I'm going to distribute that negative, so that's going to turn into a positive x minus y minus 1. I'm going to start collecting like terms, so I see that I have a pair of x's. I'm just going to move them to the front, so 3x minus 2y is equal to x minus y minus 1. And I'm going to move everything to the same side, so I'm going to subtract this x over 2x, move all the variables to one side, that is, so I'm going to subtract this x over 2x, add the y, we get a negative y here, and that's equal to a negative 1. So now I have two new equations that are going to be much easier for me to use. I'm going to choose to use elimination. I think elimination a little bit faster. And the way that I've solved these, putting the x's and y's both on one side, could also very easily solve for the y here. It'd be 2x plus 1 and then plug that in. But I like elimination a little bit better. So if I'm going to eliminate, I think the y's are easiest because we have a coefficient of 1 here. It's much easier to multiply 1 by something to get 2 than trying to make the 2's and 3's match. So I'm going to multiply the second equation by 2. I'll leave the first equation alone. I'm going to multiply the second equation by 2. So I get a 4x minus 2y equals a negative 2. So again, this was my first equation. This was 2 times the second. Now that I have these variables sitting on top of one another, I can add them very easily to get those y's to eliminate. I have 7x is equal to a 7. And so dividing off the 7, I get an x is equal to 1. Now that I've solved for my x, I can go back and solve for my y. I think the easiest equation, it looks like it's that second equation to plug into. So 2 times the 1 minus y is equal to negative 1. Well, that's a 2. And then subtracting that 2 across, negative y is equal to a negative 3. So y has to be equal to a positive 3. And we've solved it. We have the x and y that will solve the equation. Now, we didn't actually go back and use these first two equations. We only used 1 and 2 because they were simplified forms of those initial two equations. They're much easier to use, which is why I plugged back into that second equation that I created, not the actual equations given to me. 1, 3 is my solution. Come down to the second problem. Here it looks even messier. We don't have maybe as many terms, but we have a lot of fractions. We have things tied up all over the place. So I'm going to do the same exact thing where I'm going to get it in a more usable form. I'm going to get rid of those fractions. So this first equation, the common denominator is 10. Now I could get a common denominator, I could work with that in that way, but it's much easier just not to have a fraction. So I'm going to multiply everything in this first equation by 10. Well, when I do that, I multiply the first fraction. 2 goes into 10 5 times. So I'm left with the 5x. Then I move on to my second fraction, the 3 minus y over 5. Well, 5 goes into 10 2 times. The 3 minus y, I'm going to have to distribute that 2 to both terms. That 5 is being applied to both 3 minus y. I'm multiplying 10 to everything. So once I cancel that 2 that's left over, I still have to distribute to both of those two terms. So let's go and do that. We'll get a 5x is equal to a 6 minus 2y. Getting the x and y on one side, we'd have a 5x. 5x plus 2y is equal to 6. And then we have it in a more usable form. Now, if it helps to see, you can write that times 10 next to every single term. So we have 1, 2 terms. So I'm going to multiply this term by 10, this one by 10. And it's a little easier to keep track of what's canceling, what still exists. But nice, we're going to get that same 5, we're going to get that same 2. I do the same thing on the second fraction. So I'm going to look for a common denominator. And that common denominator, well, I have a 3, I have a 4, I have a 6. This common denominator is a 12. And just like before, I'm going to multiply it to every single term. So here's a term, here's a term, here's a term. I'll have to multiply it to all three things. Multiply to the first term. Well, the 3 goes into 12 4 times, so I'm going to have a 4 times x plus 2. Multiply to the next term, y over 4. Well, 4 goes into 12 3 times, so I have a 3y left over. And then finally, the negative 1 6. Well, 6 goes into 12 2 times, and so I have a negative 1 times 2, or just 2 left there. Still have a little bit more work to do. I need to distribute that 4. And next, I'm going to move the x's and y's to the same side. And so now I have two equations. I can use substitution or elimination. Again, my preference is elimination, but it really doesn't matter. You could use substitution. It's just going to be, you're going to get some more fractions. If I'm going to eliminate here, nothing is as easy as the previous example. Nothing has just a coefficient of 1. And so if I think about how to cancel the x's, I would need a multiply this one by 4, this one by 5. That would give me Bates match at 20. I could cancel that out. Or I could multiply this by 3 and this by 2, and that would get us to 6. I'd rather multiply by 2 and 3 and get a kind of matching term at 6, not at 20. It's just much smaller. So I'm going to call this my first equation, this one my second equation. I'm going to multiply 3 times the first. So that's going to give me 15x plus 6y is equal to 18. I'm going to take 2 times my second equation. So that will be equal to 8x, negative 6y, and a negative 20. I'm going to go ahead and add these two equations. And so then when we add these, we get 23x is equal to a negative 2. And then finally, to get x all by itself, we have to divide by that 23. We get x is equal to negative 2 over 23. So now that we have our x, we need to get our y. And so we have all of these different equations we can choose to plug back into. The 1 and 2, what I have labeled 1 and 2, those are the easiest. Those are my simplified versions. I don't really want to torture myself by plugging back into the 2 original. Because remember, these are all true statements. All of these equations I manipulated. So I'm going to choose one of these 2 easiest ones. And I think that this one looks just as easy as any of the others. So I'm going to choose equation number 2. So I have 4 times negative 2 over 23. Minus 3y is equal to negative 10. I multiply the 4, I get negative 8 over 23 minus 3y equals negative 10. I'm going to add that 8 over 23 over to the other side. So we'll have the negative 10 plus 8 over 23. And when we convert that back to a fraction, just because I want to use exact values, I want to use those fractions. We get negative 222 over 23, negative 222 over 23. And so now I need to divide by that negative 3. Negative divided by negative is going to be a positive. Dividing by 3, we get a 74 over 23 positive. So our solution, negative 2 over 23, comma 74 over 23. So it didn't matter that the equation started out really ugly. Those fractions were not really a big deal. We want to get rid of them because it's much easier not to have to solve with those fractions. But key is we want to get into a more workable form. So I multiplied 3 by the common denominator, got the x's and y's to the same side, and that way I could very easily either substitute or eliminate.